a correlational analysis by Darlene Whitlock for GRC 605 Business Research Methodology and Quantitative Stats, California Intercontinental University. For this video, we will be covering the following items. Definitions. We'll talk about the GRC 605's data set, 6 significant correlations, takeaways, and references. A hypothesis is a theory or idea that will predict a certain outcome. This can be tested to prove its truth or disprove its truth based on information gathered to show a relationship between variables. A hypothesis is stated by using a null hypothesis and an alternative hypothesis. The null hypothesis states that there is no relationship between the variables being considered. The alternative hypothesis says that there is a relationship between variables being considered. We are looking for a correlation. The correlation shows the relationship between the variables being considered. It is represented by the lowercase r and will always be a number between -1 and +1. The closer to +1 indicates a strong positive correlation, and the closer to a -1 will indicate a strong negative relationship. Any number that is close to 0 shows a very weak relationship, while an absolute 0 number indicates that there is no relationship between the variables. Significance is measured using a lowercase p or a p-value to show the probability of a relationship. This is the most common tool to use when determining if there is a statistical significance between the null and alternative hypothesis. Using the p-value, we can determine if a null hypothesis is true or not. Generally, a p-value is compared to the alpha value of 0.05. If it is less than 0.05, we conclude there is a significant relationship and the null hypothesis can be rejected. In the data set that we will be using, it is information that was generated on SurveyMonkey with a sample of people from the Midwest. The survey data contains several variables: the income, the debt, the savings, the stocks, wallet, number of car payments, number of credit cards, number of defaults, and using a Likert scale, the comfort level of the people taking the survey. Notice that these are all self-reported and they will help us to determine correlations between the different factors. We are looking at 6 different correlations. 6 of these will be significant. We are going to import this information into a PSPP program and run calculations. These correlations were found: income and savings, income and stocks, income and wallet, savings and stocks, savings and wallet, and stocks and wallet. Our first hypothesis tested was for income and savings. Our null hypothesis states that there is no correlation between income and savings. Our alternative says that there is a correlation between income and savings. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05. A significant correlation emerged. R equals 0.91, P equals 0.000. The test rejected the null hypothesis and concluded that there is, in fact, a correlation between income and savings. Off to the right, you can see the information generated by PSPP and the scatter plot that shows that the income and savings variables are very closely together, showing a very strong relationship between the variables. The second hypothesis test, income and stocks, shows for the null hypothesis that there is no correlation between income and stocks. There is a correlation between income and stocks is our alternative hypothesis. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha is 0.05. Looking at the information generated on the right-hand side, you can see that a significant correlation emerged. R equals 19.19, P equals 0.018. The test rejected the null hypothesis and concluded that there is a correlation between income and stocks. Taking a look at the scatter plot, you can see that the different pieces are spread out a little bit, showing a weaker correlation, but still a positive correlation. The third hypothesis test was income and wallet. The null hypothesis states there's no correlation between income and wallet. The alternative hypothesis says that there is a correlation between income and wallet. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05. You can see the results on the left-hand side. A significant correlation emerged. R equals 1, P equals 0. The test rejected the null hypothesis and concluded that there is a correlation between income and wallet. Looking at the scatter plot, you can see that it is a very direct and positive correlation. Our fourth hypothesis test was between savings and stocks. There is no correlation between savings and stocks is our null hypothesis. There is a correlation between savings and stocks is our alternative hypothesis. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05. You can see the data off to the right that was generated by PSPP. A significant correlation emerged. R equals 0.28, P equals 0.000. The test rejected the null hypothesis and concluded that there is a correlation between savings and stocks. Our fifth hypothesis test was between savings and wallet. There is no correlation between savings and wallet is the null hypothesis, and there is a correlation between savings and wallet is our alternative hypothesis. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05. Our data results are on the left-hand side. The correlation coefficient and its p-values were calculated, and a significant correlation emerged. R equals 0.91, P equals 0.000. The test rejected the null hypothesis and concluded that there is a correlation between savings and stock. Our sixth hypothesis test was between stocks and wallet. The null hypothesis states that there is no correlation between stocks and wallet. The alternative hypothesis states there is a correlation between stocks and wallet. The correlation coefficient and its p-value were calculated using PSPP, assuming an alpha of 0.05. Our data information can be found over on the right-hand side. The test rejected the null hypothesis and concluded that there is a correlation between stock and wallet. Our takeaways for correlations and PSPP are: correlation testing allows researchers to determine both positive and negative relationships between the variables. The PSPP program is an easy way to quickly analyze data sets, which allows users to easily determine relationships between variables. The PSPP analysis shows strong and weak relationships, as well as statistically significant relationships between variables. The scatter plot graphs are especially important to show this material easily. Here are the references that I used to create this presentation. If you happen to have any questions, please post them here. Thank you very much.